In this video, we're going to be talking about scale drawings and models. Our essential questions are: what are scale drawings and models? What is a scale? And how can you use a scale to determine actual measurements from a scale drawing or model? So what is a scale drawing? A scale drawing is a drawing that is used to represent objects that are too large or too small to be drawn at actual size. So on the screen here, I've got some examples of some scale drawings. This first one here is a scale drawing of a space shuttle. Very common scale drawings would be blueprints for a house. Here is a scale drawing of a cell, which is much too small to draw at actual size. And then another common representation of a scale drawing here is a map. So these are all representations of actual objects not drawn at actual size. And what is a scale model? A scale model is a model or a three-dimensional model that is used to represent objects that are too large or too small to be built at actual size. So again, here we have a scale model of a home, so you can kind of see it three-dimensionally. Here is a scale model of a commercial airline, and then here a scale model would be a globe, because building an actual model of the Earth at actual size would be impossible. And then here is a scale model of the city of Chicago downtown, so you can kind of see the city without having to be in a helicopter. So what is a scale? A scale is a ratio that compares the measurements on a drawing or model to the measurements on an actual object. So when we have a scale drawing or a scale model, we have to have a way to transfer measurements from one to the other. So if we can use a blueprint, for example, to build a house, we need to know how to take measurements from the blueprint and convert them to measurements on the actual house. Otherwise, it's going to be a very tiny house. So to do that, we're going to use a ratio, and then we're going to use a proportion to find actual measurements. And the ratio we're going to use is the model to the actual. So any measurement on the model compared to the actual measurement in reality. So when you're looking for your scale on a map or a scale drawing, you'll see something like this: 3 inches equals 10 miles. That's not actually true, because 3 inches is much shorter than 10 miles. But what this means is 3 inches on the map represents 10 miles in actuality. So we're going to take that scale and write a ratio: 3 inches for every 10 miles. And then another example here, you might see a scale that looks like this: 1 inch equals 10 feet. So again, we're going to use that model to actual ratio. So 1 inch for every 10 feet. So that's what a scale is, and we're going to use that to write a proportion to solve problems. So how do you use this scale to determine actual measurements from a scale drawing or a model? So the take-home message of today is: use the scale in a proportion to find unknown measurements. So again, we're running into this idea of a proportion that we learned back in ratio and proportion. So here is the question: how far is it from Paris to Dijon? So we've got a map, and from Paris to Dijon on the map, it is 2.2 centimeters. But it is not actually 2.2 centimeters from Paris to Dijon. That would be a very short distance to travel across France. So we're going to look for the scale. And the scale is 3 centimeters equals 200 miles. So we're going to use that scale in a proportion. So the model measurement to actual measurement ratio is 3 centimeters for every 200 miles. That's what the scale tells us. Now, the other ratio in our proportion is going to be what we know from the problem. And then we're going to set it up in the same way: the model measurement over the actual measurement. So do we know the model measurement, or do we know the actual measurement from Paris to Dijon? We know the model measurement. The model measurement is 2.2 centimeters, so that is where the 2.2 centimeters comes from. This is the model measurement. We don't know the actual measurement from Paris to Dijon. That would be in miles. But we do have a proportion set up here, and we should know how to solve that proportion, again, using vertical, horizontal, or cross product strategies. I used the cross product here. I took 200 times 2.2 and divided by 3. I'm not going to show that work because we should know how to do that. And when you solve this proportion, you find out that it is 146 2/3 miles from Paris to Dijon. So using the scale and the scale drawing to find actual measurement there. Let's take a look at another example. A scooter is 3.5 feet long. Find the length of a scale model of the scooter if the scale is 1 inch equals 3/4 feet. So here we have the actual scooter, and we know it's 3.5 feet long. And then we've got a smaller version of it, and we want to know how long that scooter would be if the scale is 1 inch equals 3/4 feet. So again, we're going to set up a proportion with the model measurement over the actual measurement for our scale, which is 1 inch for every 3/4 feet. So that's our scale. And then the other ratio is what we know from the problem. Well, do we know the model measurement? No. Do we know the actual measurement? Yes. So that's what I wrote in this ratio here. We don't know the model measurement, it's X inches, but the actual measurement is 3.5 feet. So I put those values in. Now I have a proportion and I'm going to solve this. So again, you can solve it using any of those methods. If you use cross products to solve this, you would take 3.5 times 1 divided by 3/4, and that gives you 4 2/3 inches. So the model would be 4 2/3 inches long if that was the scale. So using proportions again to solve problems involving scale drawings and models. So lastly, here we have a blueprint of a home, and we want to know what are the dimensions of the actual bedroom. So on the blueprint, the bedroom is 4 inches by 3.5 inches. And we want to know what the actual dimensions are. And then by dimensions, we mean the measurements. How large is this bedroom going to be in the actual house? So I'm looking here and I find my scale, 1 inch equals 4 feet. So that's what I'm going to start with is my scale, 1 inch for every 4 feet. And that's going to be equal to what I know and what I want to know. So I'm going to use this one here. I'm going to find the length of the bedroom first. So it is 4 inches on the model, and I don't know how many feet it is in actuality. So there's my proportion. And again, if you solve this using cross products, 4 times 4 is 16 divided by 1 is 16. So the bedroom is 16 feet long. So this measurement in actuality would be 16 feet. And then I need to find the width of the bedroom. So I'm going to do that again. And I'm going to use my same scale. 1 inch for every 4 feet equals, and on the drawing, it's 3.5 inches. And in actuality, I don't know how long it is. So again, I use my cross products, 4.5 times 3.5 divided by 1, and that will give me 14 feet. So the actual bedroom is 14 feet wide. So when I build this blueprint, the bedroom should be 14 feet by 16 feet. So again, using the proportions. So the idea here is using proportions because these relationships and these drawings and models are all proportional to their actual objects. So we use proportions to find missing measurements and the scale.